Next up is Bruce Dunn, Chair of the Material Science and Engineering Department. Bruce is the Nippon Sheet Glass Professor of Material Science and Engineering at UCLA. His research interests concern the synthesis of inorganic and organic inorganic materials and in characterization of their electrical, optical, biological, and electromechanical properties. Okay, so what does that mean? His recent work has been on electrochemical energy storage and includes three-dimensional batteries for Internet of Things applications. In other words, really fast charging batteries that you can use in your phone or in little sensors or in maybe your Ring alarm system if you don't want to run that wire out to the doorbell. Just to mention, you know, LA is such a cultural mecca, and LA Opera is fantastic. And Bruce has been a 25-year subscriber, although he did, in our discussions in the back room, admit that he can't sing a lick. But he can definitely do material science, and here to tell you about the material science department is Bruce.
Thank you. I'm not going to sing this. First, let me congratulate the students and the parents, as much of my colleagues have mentioned this before. Material science is a small department, and we have about 140 students total, and there's 14 faculty. So our student-to-faculty ratio is actually the smallest in the school. And that's a good thing in many ways because it means that the students get a lot of attention, and that's usually a good thing. Our class sizes are small, and that's definitely a good thing as well. Why is material science so small? Well, part of it is because students that are in high school are not as familiar with material science as they are compared to the other engineering disciplines. But that's okay, because material science in many ways gets integrated into all my other colleagues. So, for example, we have electrical properties that wind their way into microelectronics. We have optical properties that get into optical communication, mechanical properties of metals and composites that goes into aerospace, biomedical applications, and of course, energy is really one of the mainstays. So we're very much integrated into other disciplines, and it makes for a lot of very good, as you can tell, very good camaraderie and a lot of good jokes, and that's really part of UCLA as well. But I was also going to mention that the richness of material science has not escaped Hollywood. And in fact, you can arguably say that what's happened is that the Marvel Universe has kind of discovered material science. Now they have a different periodic table. That's not fair, you know. Nonetheless, you know, we have a lot of common themes that we can work together on. And for example, let me give you a little bit of this. One of the common themes is actually designing properties. And one of the more significant properties really is to come up with strong materials. And that's just something that transcends almost all applications. Now, Captain America, what they did to form that shield was actually something that we used in materials processing, which our students learn about very well. So it isn't as if they just completely blow this out. They don't. They really take some of the things that they've seen. Another good example is Spider-Man. He chose a tremendous fiber. He uses artificial silk. Silk, on a per-weight basis, is stronger than steel. You have to compensate for the weight, but it is actually stronger than steel. And it also has another very desirable property known as multifunctionality, because that stuff sticks to everything. So not only is it a great adhesive, it's also a great material. And then you have other things. There's all sorts of electrical properties that go on, and I won't go through all that, but certainly semiconductors are the mainstay in microelectronics, and that's where the students learn about the properties of semiconductors and how do you make them and how do you fabricate them into different sizes and so forth. And then there's also the aspect of computational learning. And in this respect, I think we're actually lagging behind Marvel, because only now are we really beginning to bring AI into the material science community, along with computer simulations as well. Then there's always biomaterials, and I won't go through these wonderful opportunities that exist here, but materials have been used in implants and sensors and continue to be widely used in these applications. And then there's optical properties. Cloaking devices have been a mainstay of science fiction forever. I don't know that we do cloaking devices now, but certainly we do camouflage. So we don't get rid of the actual object, but we are able to disguise it very well. And that's modern material science that's able to make the material look like the background. And so it's not cloaking, but it is disguising it. And then we get into energy, one of my favorite topics. Captain Marvel is an energy generator. Well, so are photovoltaics that are made from silicon, or photovoltaics that are made from perovskites. These are all generating energy. And of course, we also have the advantage that we know how to make batteries, and so we can not only generate the energy, we could store the energy for use later. And then there's that wonderful area of nanoscience. And what makes this so exciting is the fact that in nanoscience, the properties of materials at the nano level are different than the properties of materials at the bulk level, at the millimeter level. And so this means that we can now think about all sorts of new properties in much the same way that Marvel has done this. So what we're seeing here is that some of the exceptional parts of the Marvel universe, they're really based on material science. And so the takeaway that I'd like to have you come away with is that material science is really, we're design materials. We design materials that have properties that nobody can anticipate or think of, and what this does is that it enables technologies, innovation, and all sorts of opportunities for the future. And with that, let me thank you for the opportunity to get up here and talk about this and try to draw the parallels between material science and Marvel, but also to again say congratulations to the students and parents, and also I look forward to meeting the people in material science a little bit later today. Thank you.